Problem 9. An airplane is flying at an altitude of 3 miles and passes directly over a radar antenna. When the plane is 8 miles away, the radar detects that the distance is changing at a rate of 250 miles per hour. How fast is the plane traveling? All right, we need to dig out some information first. It tells us the plane is 8 miles away from the radar antenna, so this distance d we know is equal to 8. And then it says the distance is changing at a rate of 250. So it's how fast d is changing. So I know dt is going to equal 250. And then it says how fast is the plane traveling? Well, since the plane is traveling in a horizontal direction, that's going to be how fast the x value is changing. So we're going to have dx dt equals question mark. We don't know that. Okay, once we dig out our information, we need an equation. I notice that I have 3 sides of a right triangle, so Pythagorean theorem is the way to go on this one. So looking at my picture, I have 3 squared plus x squared equals d squared. Do not introduce a, b, and c because those are not the letters that are used in my actual picture. Okay, now from here, we're going to go ahead and take the derivative because that's what we do after we find our equation. The derivative of 3 squared, which is 9, since that's a constant, is just 0. The derivative of x squared is 2x dx dt, and then equals the derivative of d squared is 2d dd dt. Okay, now I'm just going to start plugging in information. I have 2. I do not have my x, which guess what? Woohoo, time for a side trip. And now we're going to take this original equation. We do know that d is 8, so I have 3 squared plus x squared equals 8 squared. So it's going to give me 9 plus x squared equals 64. That gives me x squared equals 55, so x is equal to the square root of 55, and I would strongly recommend leaving that as a square root until the end of your problem. Okay, so now I have 2 times the square root of 55 dx dt is equal to 2 times d, which is 8, times dd dt, which is 250. All right, simplifying this, I will now have 2 square root of 55 dx dt is equal to 4,000. And then to get dx dt by itself, I'll just divide by 2 square root of 55. You may leave your answer like this. If you're going to work it out to a decimal, please make sure you put the denominator in parentheses. And when you do that, you're going to get dx dt is equal to 269.680 miles per hour. Okay, problem 10. A rocket is rising vertically at a rate of 2,800 miles per hour. An observer on the ground is standing 5 miles from the rocket's launch point. How fast is the angle of elevation between the ground and the observer's line of sight of the rocket increasing when the rocket is at an elevation of 30 miles? All right, again, I'm going to pull out some information. It says the rocket is rising vertically at a rate of 2,800 miles per hour. So that's telling me how fast the h is changing. So I know that dh dt is equal to 2,800. Okay, and the observer is standing 5 miles away. That's not going to change. The observer's not moving. And then it says how fast is the angle changing? So I want to know d theta dt. So I'll put equals question mark. And then it says when the rocket is at an elevation of 30 miles. So elevation is height. So we want to know h is 30. So I've got my information. The next thing I need is an equation. And since this is a problem with an angle at it, I'm going to use SOHCAHTOA, and I'm going to pick tangent. So the tangent of theta equals opposite over adjacent, which in this case would be h over 5. And I'm going to rewrite this problem before I take the derivative. Another way of writing h over 5 is 1/5 h. And now once we get our equation, the next step is to take the derivative. The derivative of tangent, hopefully you know, is secant squared theta. We also do need to include that d theta dt. And then the derivative of 1/5 h is just 1/5. And then again, we need to include dh dt. So now I can start trying to plug in information. I get secant squared. Here I'm stuck because I don't know theta, so it is time for a side trip. Okay, so my side trip, I'm going to go from tangent theta equals h over 5. Well, I know that h is 30, which equals 6. And so I'm going to have, to get theta by itself, I'll take the inverse tangent of 6. And when I do that, I should be in radians right now. I will get 1.405648. Please round to enough spaces here so that your answer is accurate when you're done. So I just went out a ton of spaces. 1.405648. d theta dt equals 1/5, and I know that dh dt is 2,800. Okay, from here, getting secant squared, please remember on your calculator, it's going to be 1 over cosine of 1.405648 squared. If you put parentheses in your problem just like I do, you will get the right answer. And then I don't even think, excuse me, I don't even think from here I actually figured that out yet. So when I got this answer, and I want to be accurate, I'm going to go out probably 5 or 6 spaces. When I'm done with it, I will divide both sides by that, and you should get d theta dt is equal to 15.135, and since it's an angle we're measuring it in radians per hour. Okay, problem 11. The position of a particle moving on a line is s of t equals 3 cosine 2t minus 5t. All right, part A, find the formula for velocity and acceleration. Velocity is going to be the first derivative. Acceleration will be the second derivative. I do notice I have parentheses here, so we are going to be doing a u substitution. So I'm going to have 3 cosine u. So velocity is equal to the derivative of position. So the derivative of 3 cosine u is negative 3 sine u times the derivative of u. The derivative of 2t is 2. So this will be negative 6 sine of u, which is 2t, and then minus the derivative of 5t is 5. So that's the velocity. The acceleration is going to be the derivative of velocity. And once again, I'm going to put that u back in. So I'm just going to come down. Where do I want to put this? Negative 6 sine u minus 5. This is u. All right, so the derivative of negative sine u is negative 6 cosine u, and times the derivative of u, the derivative of 2t is 2. So this will give me negative 12 cosine u, and the derivative of minus 5 is just 0. So the acceleration is going to be negative 12 cosine of 2t. So I've answered part A, and then from here, to get part B, so that was part A, find the velocity of the particle at t equals 8.46. So I already have a formula for the velocity. So if I want the velocity at 8.46, I'm going to go to my velocity formula, negative 6 sine, and here I'll have 2 times 8.46 minus 5. I will make sure that I'm in radians when I'm doing this problem, and it should turn out to be 0.618 if you do it correctly. All right, number 12, multiple choice. Given that f of x has a relative minimum at x equals negative 3, choose the correct statement. All right, before I even look at these, it says f prime being positive and negative or both. As soon as I see something about a relative minimum and I see they're talking about a derivative, I know that I would like to draw an f prime chart. And if there's a relative minimum at x equals negative 3, I know that f prime needs to be changing from negative to positive. So I basically just have my answer on my chart. I just need to figure it out. So part A says f prime is negative on the interval from negative 3 to 3. So if I start at negative 3 and head towards 3, the interval that is not negative. So no B, no A. B, f prime is negative on the interval negative infinity to negative 3. So over here, that is correct that f prime is negative. So yes, B is an answer. All right, C, f prime is positive on the interval negative 3 to infinity. Negative 3 to infinity right here. Yes, that is correct that f prime is positive there. And D, no, f prime is not negative on the interval negative 3 to infinity. So no. So my answer, since both B and C worked, it is going to be